OSI Reference Model. So up until now, we've been introducing you to the concept of a network. But that's the first chapter. Now, since we're beginning the second chapter, we want to talk about the OSI reference. So here's the content of the OSI reference model. First, we'll have a brief look at the internetworking models. Then we'll talk about the OSI reference model. And then finally, we'll cover the subject of encapsulation. So way back in early networks, computers could only communicate with computers of the same manufacturer. To eliminate this problem, the International Organization for Standardization developed the OSI model. Now, the purpose here is to define how the communication between the two computers will be. So this standard, which was first revealed in 1978, was published as an OSI, Open System Interconnect, reference model in 1984, with the help of new regulation. In the pre-OSI era, there were networks specific to organizations that produce computer hardware only. The properties of these networks were often defined to allow only that manufacturer's hardware to be connected. The OSI model does not differ according to any type of hardware or computer network. In fact, the purpose of OSI is to enable network architectures and protocols to be used as a component of a network product. Now, the OSI model is divided into 7 layers. So in short, a reference model is a conceptual blueprint for how communication should take place. It takes all the processes necessary for effective communication and divides these processes into logical groups called layers. Each layer has different tasks and communicates with the same layer on the device it's communicating with. When a communication system is designed in this way, it's known as a layered architecture. So let's say you start a company. When establishing this company, you will assign different people to each department. For example, we'll assume that there are departments such as human resources, advertising, and accounting. So the people you assign in human resources don't actually interfere with the affairs of the accounting department, and those in the advertising department do not interfere with the work of human resources, right? So each department is responsible for its own work. So within this scenario, I'm using departments as an example for layers in a communication system. For things to run smoothly and correctly, the staff of each department must do their job. They must rely on others to competently carry out their own unique responsibilities. So OSI is a reference model for how applications can communicate over a network. A reference model is a conceptual framework for understanding relationships. The purpose of the OSI reference model is to guide vendors and developers so that digital communication products and software programs that they create will interoperate, and to facilitate clear comparisons among communication tools. So most vendors involved in telecommunications attempt to describe their products and services with the help of the OSI model. And although useful for guiding discussion and evaluation, OSI is rarely actually implemented, as few network products or standard tools keep all related functions together in well-defined layers as related to the model. Developed by representatives of major computer and telecommunication companies beginning in 1983, OSI was originally intended to be a detailed specification of actual interfaces. But instead, the community decided to establish a common reference model for which others could then develop detailed interfaces, which in turn could become standards. OSI was officially adopted as an international standard by the International Organization of Standards, which we refer to as ISO. So not to be confused, the main concept of OSI is that the process of communication between two endpoints in a telecommunication network can be divided into 7 distinct groups of related functions or layers. So each communicating user or program is at a computer that can provide those 7 layers of function. So in a given message between users, there will be a flow of data down through the layers in the source computer, across the network, and then up through the layers in the receiving computer. The 7 layers of function are provided by a combination of applications, operating systems, network card device drivers, and networking hardware that enable a system to put a signal on a network cable or out over Wi-Fi or some other wireless protocol. The 7 open systems interconnection layers are the application layer. This is the layer at which communication partners are identified. Is there someone to talk to? Network capacity is assessed. Will the network let me talk to them right now? And that creates a thing to send or opens the thing received. Now, I want you to please note that this layer is not the application itself. It's a set of services an application should be able to make use of directly, although some applications may perform application layer functions. The presentation layer. This layer is usually part of an operating system, or OS, and converts incoming and outgoing data from one presentation format to another. For example, from clear text to encrypted text at one end and back to clear text at the other. The session layer. This layer sets up, coordinates, and terminates conversations. Services include authentication and reconnection after an interruption. On the Internet, Transmission Control Protocol, or TCP, and User Datagram Protocol, UDP, provide these services for most applications. The transport layer. This layer manages packetization of data, then the delivery of the packets, including checking for errors in the data once it arrives. On the Internet, TCP and UDP provide these services for most applications as well. The network layer. So this layer handles the addressing and routing of the data, sending it in the right direction to the right destination on outgoing transmissions and receiving incoming transmissions at the packet level. IP is a network layer for the Internet. The data link layer. This layer sets up links across the physical network, putting packets into network frames. This layer has 2 sublayers, the logical link control layer and the media access control layer. Ethernet is the main data link layer in use. The physical layer. This layer conveys the bit stream through the network at the electrical, optical, or radio level. It provides the hardware means of sending and receiving data on a carrier network. Now, when a computer transmits data to another device over the network, the data goes through encapsulation. That is, it's wrapped in protocol information at each layer of the OSI model. New information is added at each layer, and each layer uses protocol data units, or PDUs, to communicate and exchange information. PDUs are called segment at the transport layer, packet at the network layer, and frame at the data link layer. Finally, the data is converted into bits in the form of zeros and ones to be transmitted in the physical medium. Layers communicate only with the same layer on the receiving device. you should know the sublayers of the data link layer. In addition to the OSI layers, the only layer that has sublayers is the data link layer. And it's extremely important to know the functions of these sublayers. The data link layer has two sublayers, LLC and MAC, Media Access Control. So the LLC sublayer is primarily responsible for multiplexing network layer protocols. The MAC sublayer is responsible for physical addressing and determining the appropriate time to place data on the network.